Hello students, in this video we are going to solve the problems of exercise 5.8 of NCERT textbook of mathematics class 12 of the chapter continuity and differentiability. So hope you will like the video. So let's start. So here differentiate the following functions from 1 to 10 with respect to x. So here is the first function e to the power x by sin x. So let me show this one. So first one, suppose y is equal to e to the power x by sin x. So here we are going to apply u by v, that is quotient rule. Its derivative is given by the denominator v, derivative of the numerator minus numerator derivative of denominator by denominator square, that is v square here. So consider e to the power x as u and sin x as v. Then what will happen according to this rule? So then we will get y dash, that means you can write dy by dx. If you differentiate with respect to x, then here denominator is sin x, derivative of e to the power x minus e to the power x numerator, then derivative of the denominator, derivative of sin x divided by sin square x, that means square of the denominator. So now sin x, we know derivative of e to the power x is e to the power x, then minus e to the power x, derivative of sin x is cos x, and then here it is sin square x. So from the numerator part, what we can do, we can take e to the power x common. Okay, we can take e to the power x common from these two terms. So e to the power x, and then we have got sin x minus cos x divided by sin square x. So that's our result. Now let me show you the next one, that is question number 2. This is the second function. So let me clean this first. Now number 2. So here y is equal to e to the power sin inverse x. So therefore dy by dx is given by derivative of e to the power sin inverse x. Now you see, assume this is x, then what will happen? Derivative of e to the power x is e to the power x. So here instead of x there is sin inverse x, and then again you see this is not only x, this is a function of x again. So again we have to write derivative of sin inverse of x. So it's function of function, and derivative of sin inverse of x is nothing but 1 by root over 1 minus x square. So here our answer will be e to the power sin inverse x divided by 1 minus x square. So this is our final answer. So hope you have understood this. So now let's move on to next question, that is question number 3. So here is the function e to the power x to the power 3. So let me clean this first. So similarly we can solve this one as well. So number 3, so y is equal to e to the power x to the power 3. Now assume this one as only x, then dy by dx is equal to derivative of e to the power x to the power 3, then it will be given by e to the power x is e to the power x, derivative of e to the power x is e to the power x, then again x cube is also a function of x, then derivative of x cube again, and derivative of x cube is nothing but thrice x square. So here our answer will be 3 e to the power x cube into x square. So this is our result. So hope you have understood this. So let me write here x cube. Okay, so this is the result of third one. Now let's move on to question number 4. Now let us solve 4. So here y is equal to sine of tan inverse of e to the power minus x. So here first assume this part as x only, so you can assume as sine of x. Okay, if you assume this one sine x, then dy by dx is equal to derivative of sine of tan inverse e to the power minus x. So here we know derivative of sine x is cos x, isn't it? So here assume this one as x, then our result is gonna be cos of tan inverse of e to the power minus x. Then again derivative of the function within bracket, that is tan inverse of e to the power minus x. Now here again you have to assume this one as tan inverse of x. If you assume this one as x, then what will happen? So what you will get? So we know that derivative of tan inverse of x, derivative of tan inverse of x. So what is the result? It is equal to 1 by 1 plus x square, isn't it? So instead of x square, here we have to write e to the power minus x whole square. So our result will be cos of tan inverse e to the power minus x. Here it will be 1 by 1 plus e to the power minus x whole square. Then again here you see this is again another function, so you have to write derivative of e to the power minus x. So e to the power minus x can be assumed as e to the power minus 1 into x, and we know derivative of e to the power mx is given by is equal to m e to the power again mx. So here derivative of e to the power minus x will be minus 1 into e to the power minus x. So our result will be, final result will be, so let me clean this part here, cos of tan inverse of e to the power minus x into 1 by 1 plus e to the power minus twice x, and derivative of this one is minus 1 into e to the power minus x. So this is the result, so which can be written as, so let me rearrange this. Okay, so it can be written as minus e to the power minus x cos of tan inverse of e to the power minus x divided by e to the power minus 1 plus e to the power minus twice x. So this is our final result. So that's how we can solve this question number 4. Now let me show you how to solve question number 5. So solution of 5. So y is equal to log of cos of e to the power x. Now assume this whole part as x. So dy by dx, we know, first let me write as this, log of cos of e to the power x. Now we know ddx of log x is 1 by x, so here we will get instead of x cos of e to the power x. Again you see, as this part is another function, so derivative of cos of e to the power x. Now here again you have to assume e to the power x as only x, then you have to differentiate it as cos x. So we know derivative of cos x is minus sin x, so here we will get minus sine of e to the power x by cos of e to the power x. Again, this is another function, so that's why again you have to differentiate it separately. Again, derivative of e to the power x, we know derivative of e to the power x is again e to the power x, so our final result will be minus e to the power x sine of e to the power x by cos of e to the power x. So now here you see, we know that sin x by cos x, sin x by cos x is 10x, so it can be written as minus e to the power 10 of e to the power x. So this is our result. So that's how we can solve the fifth. And now let me show you the next. Now 6 here, e to the power x plus e to the power x square plus next term must be e to the power x to the power 3 plus then e to the power x to the power 4, then e to the power x to the power 5. So here you see what we can do here. So dy by dx, so we can assume those as sum of functions. So in that case, simply we need to find the derivative of first function, then plus derivative of the second function, and so on. Sorry, here it should be 4. Now here you see derivative of e to the power x to the power n is what, if you differentiate this, so assuming this one as x only, then derivative of e to the power x is e to the power x. Again derivative of x to the power n, that is n into x to the power n minus 1, isn't it? Sorry, here we have assumed this x to the power n as x, so here x to the power n should be there. So final result should be n x to the power n minus 1 e to the power x to the power n. So this should be the final result. So you have to apply this here. So what we have done, so we have assumed this one as x first, and e to the power x is e to the power x. This one we have got. So considering this one as x, but it is not actually x, it is x to the power n. Again we have to differentiate x to the power n, and derivative of x to the power n is n into x to the power n minus 1, and this one is written here. So we have got this. So we will get the answers. We will get the derivative of these functions in this form. So what we will get here, so let me clean this part. So here derivative of e to the power x is simply e to the power x, and in the next one, so here we will get 2x e to the power x square, then again thrice x square e to the power x cube, then next one will be 4x cube, then e to the power x to the power 4, then 5 e to the power 5 x to the power 4, then e to the power x to the power 5. So this is our final result. That's how we can differentiate. So hope you have understood. Now let's move on to next question. Now let me solve 7. So here y is equal to root over e to the power root x. So here x is greater than 0, it is given. So now let us find the derivative of this. Dy by dx will be derivative of root over e to the power root x. Now you see here you can assume this whole thing as x. Okay, we can consider this one as root x. Then we know derivative of root x is 1 by 2 root x. Okay, so if you apply this, then you must get 1 by 2 root e to the power again root x. Then after differentiating this, again you have to differentiate this function under root, that is derivative of e to the power root x. Now assume this one as x only instead of root x. If you differentiate this, we know derivative of e to the power x is e to the power x only. So here we will get again e to the power root x. Instead of x there is root x, then 2 root over e to the power root over x. Then again you have to differentiate this function, as here you see it is not only x, it is root x. Again you have to differentiate this derivative of root x, and we know again derivative of root x is 1 by 2 root x. So if you put this, then what you get, e to the power root over x by 2 into root e to the power x, then this is again 1 by 2 root x. So our final result will be, so what will be the final result? Now here you can see one more thing. If you cancel this down by this denominator, so if you assume this one as x and this one as root x, if you cancel x by root x, then you get root x, isn't it? So if you do so, then what you will get? So here you will get e to the power root over x. So our final result will be e to the power root x, sorry, here you should get root over e to the power root x, isn't it? So let me explain again. So here it is e to the power root over x, and here we have e to the power root over e to the power root x again. So you assume this one as x and assume this one as root over x. So if you cancel this one, if you cancel this x by root x, then you must get here root x. So then our result gonna be, so that's why if you cancel these two, then here you should get e to the power root over e to the power root x. So our result will be this, will be the final result. Here 2 will be 4 root x. So this is our final result. So that's how we can solve question number 7. So hope you have understood this, and or you can keep the answer this way also. Instead of cancelling these two, you can keep it like this also. If you don't want to cancel, then you can keep the answer as it is. Sorry, you can keep this one as like this, 1 by 4 e to the power root over x here, then sorry, you can keep the answer like this also, e to the power root over x by 4 root over e to the power root x into root x. So this is our final answer. You can keep the answer this way. So hope you have understood. Now let me show you the next one, that is 8. So solution of question number 8. Now y is equal to log of x. Okay, so here it is very simple, dy by dx, derivative of log of x. So now assume this part as x only, then we know derivative of log x is 1 by x, so here it will be 1 by log of x. Again you have to find the derivative of the function within the bracket, that is derivative of log of x. So again we will get here 1 by x into log of x. So this is our sum, this is our answer. That's very simple. So now let's move on to next question, that is question number 9. Here we are going to apply the quotient rule, u by v, derivative of u by v. So let me show you how to do that. So here, okay, so number 9, y is equal to cos of x by log of x, where x is greater than 0. So dy by dx, here according to the quotient rule, so derivative of u by v, so v derivative of u minus u derivative of v by v square. Now assume this one as numerator as u and the denominator as v, then what you will get? So So log of x derivative of cos x minus then cos x derivative of log of x by log of x whole square, that is b square. Okay, so let me write here properly. Okay, now what you will get, we know derivative of cos x minus sin x and derivative of log x is 1 by x. So here we will get minus sin x, and from here we will get 1 by x. So if you substitute this value here, we will get minus log x sin x, and here we will get minus cos x by x, and here it is log of x whole square. So this is the answer, very simple. So hope you have understood this. Now you can do simplification here also. If you want to simplify, yeah, you can multiply both the numerator and denominator by x. If you multiply here x and here also x, then what you will get, if you multiply both the numerator and denominator by x, then you will get minus x log of x sin x minus cos x by x log of x whole square. So this is how you can write the answer. So maybe in your book the answer may be in different form, but it is not wrong. Okay, so now let's move on to next question. So here is the last question, question number 10. So let me solve this. This is here y is equal to cos of log of x plus e to the power x, where x is greater than 0, it is given. So derivative of this function, derivative of cos of log of x plus e to the power x. So first assume this one as x only, this part as x. So here we can assume this as cos x, and derivative of cos x is minus sin x. So x is this one, so that's why we will get minus sine of log x plus e to the power x. Now again you see, actually this is not x, this is sum of two functions. Again you have to find the derivative of this. Sorry, here let me write this part here. Okay, so again you have to find the derivative of log of x e plus e to the power x. Okay, then again here sum of these two functions, so minus sine of log of x plus e to the power x. You can find the derivative of log of x plus again log derivative of e to the power x. So what will be the result then? Minus sine of log of x plus e to the power x, and derivative of log x is 1 by x. So this is 1 by x, and derivative of e to the power x is simply e to the power x. So that's our final answer. So hope you have understood. Now this exercise is completed. So in the next video we're gonna solve the problems of next exercise. So thank you for watching. If you like my videos, please hit the thumbs up, and if you are new to my channel, subscribe the channel and share the videos with your friends. So if you think these are helpful, and please subscribe the channel to support me and inspire me to create new contents for you. Thank you for watching.